super excited to be talking about processing today. We talked about it a little bit last week. We're going to talk about it today, then we're going to do one of these again next week. So if you're into this, feel free to come back next week as well and spread the word. There's also a ton of other workshops happening through Duke Create and through the CoLab. So keep your eyes on their schedules too. Yeah, just because we're sort of isolated at home doesn't mean that we can't keep making stuff and keep learning stuff. So yeah, so I'm really excited to be talking about processing. If you don't know about processing, it's a programming language that is specifically tailored to making visual things, and it can be used to generate still pictures. It can be used to generate animation. Can be used in installation settings and all sorts of wild video processing and image processing capabilities and stuff like that. And I started using it about a year and a half ago. And I've been sort of self-taught in it. There's a really great web series on YouTube called Coding Train, which is run by this guy named Daniel Schiffman, and it's a phenomenal series, and it's really great. So if you're like what you see today, you can check out those videos for more information. So yeah, let's get started. I'm going to share my screen so you can see what I'm doing. I'm just going to share my desktop. So I have the processing website up just in case I need to look anything up. They have a really good reference page with all this stuff. So there might be a moment where I pop over to that if I forget some things or if I need help with some things. So this is your main coding window. You got your sort of display down here. If you ask the program to print some things out, it'll come out down here. And then to run your code, you just click up here, or you click there to stop, and that's about all you need to know. So let's get started. We're going to make a bunch of circles today. So the first thing we need to do is we need to create a void setup block of code. And this setup just runs once and sets the basic parameters for your sketch. These are called sketches. So the first thing we're going to do is give it a size. We're going to say size 800, 800, and that's how many pixels. This is your width, and this is your height. So it's going to be a square canvas that we're working on. Then I'm going to tell it to use its smoothing. That makes the animation just a little bit nicer to look at. And that's all I'm going to do up there for right now. Then I'm going to come down here and I'm going to make a draw loop. So the setup loop runs once at the beginning when you run your sketch, and the draw loop runs continuously. It just keeps going over and over and over again unless you tell it not to. So the first thing I'm going to do is I'm going to say background 100, and if I run this right now, that's just going to give us like a gray background. This is 800 pixels across, 800 pixels down, just like we asked it to. And in processing, 0, 0 is up here in the top left corner. So keep that in mind. And the first thing we're going to do is we're just going to draw a circle. So we're going to use the ellipse. And we're going to say 0, 0. That's the first point of the circle. And then that's actually the center of the circle. And then we're going to give it a diameter that's going to be 400 across and 400 tall. So because this is an ellipse, I keep saying circle, but I should really say ellipse. Because this is an ellipse, these parameters here don't have to be the same. They can be any numbers, and it'll stretch the ellipse to fit the shape that you ask it to make. So if I run this, we have a circle. We have sort of a quarter of the circle because remember 0, 0 is up here. So when I said 0, 0, it put it right there, but it's in the top left corner. and I don't want it to be there. I want it to be in the middle. So I'm going to use the translate function, and so what this does is this moves our canvas around. So I'm going to say translate the 0, 0 point to the middle of of our canvas, and to do that, I'm going to say width divided by 2, and then height divided by 2. So that's going to take our 0, 0, and it's going to move it halfway across and halfway down, which will put us smack dab in the center. So if we run this, then we got a circle in the center. Okay? So I'm just going to pause just for 1 second just to make sure everyone's cool with that. No one has any questions. Everyone's getting that to work.
So Brooks, why would you do that rather than just making your ellipse X and Y the center points of the canvas?
It's a great question. So I'm doing that because a lot of the next steps that we're going to do involve things rotating around our 0, 0, around the middle of that circle. So, I mean, I could, like, I don't have to translate it. I could have designated a central point and name that central point something, and referred back to that all the time. But it's just a little bit easier to say 0, 0 is in the middle, and everything in our world is going to sort of rotate around that.
Makes sense.
Yeah. Okay. Now I want to make this ellipse a little bit different. So I'm going to use this thing called push, and then I'm going to come down here below this and say pop. And what this does, what push and pop do, is they sort of make a little imaginary bracket around the code that they enclose, and they say all of the attributes that I give in this block of code only apply to this little block of code. So I'm going to change some things here about this ellipse, and I'm going to say the first thing is I don't want any fill. So when I run that, we're not going to have that ugly white in the middle. It's just going to be that outline. And then I'm going to change the stroke to 255. And this is talking about the color of the stroke. So right now we're working with RGB. We might change our color mode in a second. But if we give just one number here, that's a black is 0, white is 255, and it's a value along that. So if I run this now, it's going to be a white outline of a circle. Okay? So I want to make another circle, and the goal is to make a circle that orbits sort of around that outline that we drew. So I need to create a couple of variables. So I'm going to do that up here at the top. I'm going to make a float that's called center, because I need to know where the center of my circle, that my rotating circle, is going to be. So that's a float called center. Then I need to have 2 more things. One of them is going to be called sign center or sin center. And then the other thing is going to be float COS center. So I don't remember that much from high school geometry, but what I do know, and this mainly comes from, because I work with music a lot and I work with synthesizers a lot, I know that sine waves sort of trace a path that goes up and down in a sinusoidal pattern, and I know that cosine waves do that, but in the opposite. So we're going to leverage that cosine-sine relationship to make our circle travel in a circle, okay? So we're going to come down here below that outline that we made, and we're going to say sine center equals sine of center. And this is sometimes in programming you name things, and then you write things that are very close to those names, and you have to just sort of keep your syntax in your mind. So like this sin underscore center means something wildly different from sin with center in parentheses. So this is saying this variable sign center, every time we run through this, we're going to calculate the sign of center and assign it to this variable sign center. So what we need to do is we need to update center every time we run through this loop. We need to increment it. So what we're going to do is we're going to say center plus equals 0.01, and that with the semicolon. I should say, I sort of skipped over that. All these lines end with semicolons. You're going to get really good at figuring out where that semicolon button is as you use processing. So what I want to do, just to sort of, so I can see that this is working, I'm going to use a command called println. And println means that every time it prints something, it prints it on a new line. So it's a lot easier to see. If you just say print, it just sort of scrolls across lines and doesn't put any line breaks in, and sometimes it's difficult to read. So println is very clutch. And I'm going to println sign center. And then if I run this, our circle is just stationary, but if we look down here, we see that this value is changing, and it's going from -1 up to +1. So we just hit +1, and now we're going back down to -1. And it's just going to keep doing that over and over and over again. So that's cool that we have that, but going from -1 to 1 on our screen is just going to be a tiny little change. It's going to barely move if we asked it just to do that. So what we need to do is we need to map that -1 to 1 to a larger value. And so there's a really handy function called map. So up here I'm in the sign center line. I'm going to start this with a map and then a map and then a parentheses. And the way that the map function works is it takes 5 variables. So it takes in the incoming source, so where we're getting our data from, and then the next 2 are the range for that data. So I put a comma, and then we know that the lowest value for our sign is going to be -1, and the highest value is going to be 1. And then we want our output values for this. We want the lowest one to be -200, and then our largest one to be 200. So now, if we run this, our value should go from -200 up to +200. Oh, I messed that up. -200 to +200. There we go. And you won't necessarily see 200 exactly in your readout, and that's just because of the rate that the readout happens. It's not giving you every single pass through of the draw function. It's just giving you as much as you can without overloading itself. So if we come down here and we make a new ellipse, and then for the x value, or for the first value, if we put sign center, and then let's just put 100 for the y value, and then let's make it 50 pixels by 50 pixels wide and tall. If we run this, we'll have a circle that just sort of moves back and forth, left to right. Okay, and that's because we're using this sign value for the x, and then for our y, we're keeping that steady. So our y, remember, is not changing, so it's just staying on that one axis. Okay. So now we have that other variable called cosine of center. So all that we're going to do is we're just going to copy this line of code, paste it directly under, and then whenever you see that SIN, just change that to COS. It's going to be there and there. So now we're taking this center value and we're passing it into sine and cosine, and then we're mapping both of those from -1 to 1 to -200 to +200. And then if you can sort of read my mind, we're going to take this cosine of center and we're going to pop it here in our y value. So now the x value is controlled by the sine of center, and then the y value is controlled by the cosine of center. And now if we run this, our circle moves on our circle path.
Cool.
Okay, I'm going to take a second and see if anyone has any questions to make sure everyone their circles are doing what they're supposed to do. Okay. With the little response, I'm guessing that everyone's cool. So, so this is great, and this is really fun. But I want to make a bunch of circles, and so what I'm going to do is I'm going to make this circle here that we have that's rotating. I'm going to make that an object. So processing and some other languages are object-based languages. And so if you make an object, you can give it some attributes and you can define some things about it, but then you can make a whole bunch of those objects with variable values and independent values and all these different cool little attributes that you can have the computer play with, or you can play with. So I'm going to make a thing called circle object, and when I type that, it says there's a syntax error and doesn't recognize this circle object thing, because it doesn't, like, if I type in float, it knows what a float is, but it doesn't know what a circle object is because I haven't created a class of objects called circle object. So we're going to do that right now. So click up here and make a new tab. And it's going to ask for a name for this file, and just put in circle obj. Hit OK. And then we have a new tab. And you actually don't have to do this in a new tab. You can do this all in the same sketch tab. But I like to do this just so I can sort of keep my information organized and separated. So in this circle object, the first thing I need to do is say class, because we're making a new class, and I'm going to name that class circle obj. And then I'm going to open up curly brackets, and then give myself some space, and then close those curly brackets. So that says that everything that's going to be within this code is going to be part of this class circle object. Okay? Then, to get set up, I basically need to make a sort of similar structure to this sketch. So I'm going to say circle object, or obj, and then put some parentheses, which are going to come in handy later. And then do that, put in some curly brackets, and then I'm going to make two functions that happen in this circle object class. The first one, I'm going to say void update, and then I'm going to do curly brackets with that. And then I'm going to say void display, and then I'm going to make some curly brackets for that. So, why is this? Huh. That shouldn't. Let's see if I can fix that. So basically what's going to happen is this is going to be like our setup. The way that our setup over here runs once at the beginning, this circle object bit of code is just going to run once, and it's just going to initialize our circle object. Then these updates and display, we're going to call these in the draw loop of our main sketch, and those are going to be updated continuously. Okay? So all we're going to do is just take all the information from our main sketch that has to do with this circle that's rotating, and just plop it into the corresponding place in this circle object class. So all of these floats that we initialized, I'm going to cut those and drop those here at the top. We have those and they're ready to go. And then when we come down here,
I have a question,
yeah,
if that's okay. Okay, what is the float? Like, what does that do?
this stuff up here that I just copied and pasted.
Yeah.
Yeah, great question. So what this is going to do when we call a circle object, this is going to tell the computer that when you make a circle object, you need to make a floating point number, so like a number with a decimal. You need to make a floating point number that's going to be called center. And so we're going to use that as a variable within this, and so get ready for it because it's coming.
So that's like where the circle will be?
Yeah, this is gonna be, these floating points are gonna control where the circle is, yeah.
Okay.
Yeah,
Thank you.
yep, good question. Okay, so then, so we have these two functions here, update and display. The update is gonna be where we do the math to figure out where the circle should be. And then the display is going to be drawing the circle and playing with sort of how it looks. So this stuff here, all this sign of center stuff, this is all talking about where the circle is going to be. That's all the math part. So we're just going to we're just going to cut that. And then we're just going to paste that in this void update. Yeah, the thing that's a little bit harrowing about making classes like this is that there's sort of a long period of time where you can't run your code. Like you have to do a lot of sort of moving of data around before you can check anything, and so there's sort of a chance that once you move everything over and you hit run, it's not going to work, and you're going to be like, okay, I just copied a bunch of stuff and I don't know what I miscopied. So that might happen to us. I'm hoping it doesn't, but it might. Okay, then this display function, we're going to cut this, because this is talking about where to display our circle. And that's all that we need for now. Why is this telling me that that's not how it should be? Huh.
What's on your first page? Are you calling it and something else on the first page?
Oh, you know what? It's because I haven't done this. Maybe that's right. Maybe because I haven't made it yet. Okay. So, anyways, I'll keep rocking, and if that throws up an error, we'll debug that. So, just like how we made it, like whenever we need to make a variable, we say float, and then we say, x, right? And that tells the computer that it needs to make a float variable that's called x. So we need to tell the computer that we want to make a circle object, which it now knows what a circle object is, and we're going to call that circle object mover. Okay? Because that's the thing that moves. Then in the setup, we're going to say mover equals new circle object. And then we're going to do parentheses like that, and then put a semicolon at the end. And so this says, okay, make a circle object called mover, and then this says that mover is actually going to be a new circle object. It's a little bit redundant, and I can't exactly explain why you need to do it, but you need to do it. Then, when we get down here in our draw loop, we need to call those two functions that we wrote. So we need to call mover.update, put some parentheses and a semicolon, and then mover.display. Okay? And now if we run this, did I not spell this correctly? There it is. Yeah, check your spelling. Okay, now, if we run this, we have exactly what we had before. We did all that work. and we got exactly what we had before. So that's good. It's actually really good. It means we didn't break anything along the way. Okay, is everyone cool with making an object? Is everyone's objects working? This was the part that
I
I
have a
was.
quick question.
Yeah.
In your object void display and void update, are those processing syntax commands, or are those just the way you've decided to call upon them?
Yeah, great question. This is just the way I decided to call upon them. There's a couple words you can't use. You can't use draw, because draw is like is an already known quantity for processing, because we use draw here. So you can't use draw and you can't use setup. Okay. So or other things. I think you probably couldn't use like void. Well, I don't know. But so anyways, yeah, these are just me reminding myself what these functions do. So this one is the math part, so it updates the location, and this one is the display one, which we're going to get deep into here in a second, which is going to control how the circles look. Okay? So, okay, this is cool, but we've only made one circle, and I want to make like 1,000 circles. So what we need to do is we need to make this this mover, need to make this an array of circle objects. So I'm going to come up here, and after my first calling of circle obj, I'm going to put square brackets. Okay, and these start to tell the computer that this is going to be an array of these circle objects. Okay. So this syntax gets a little bit heavy. So I'm going to be really careful when I do this. So circle object, square brackets, and I'm calling that array mover, and I'm going to say new circle obj, and then this time when I give the brackets, I'm going to give a number. So I'm going to say how many of these things I want to make. So I'm going to say 3 for right now. So then in the setup, this is saying, okay, this is a mismatch. This is, you're asking for an array list, but you're only giving me not the information that I need. So in order to make all of the movers to fit within that array list, I'm going to say for, this is our for loop, int I equals 0. So I'm initiating an integer called I and setting it to 0. Then I'm going to say while I is less than 3, because I have 3 up here. While I is less than 3, it's going to run this loop, and I'm going to increment I every time we run through it. I'm going to close those, close that parentheses, then open up some curly brackets. And now, in the for loop, when I make these movers, I'm going to put a square bracket here, and I'm going to say I. So what this means is that it's going to make a mover, and it's going to say this is the ith mover in the array list. So it's going to start with 0. It's going to run through this, and it's going to say mover number 0 is a new circle object. And then when it runs through it the next time, it's going to say mover number 1 is a new circle object. Mover number 2 is a new circle object. Okay? Then I'm going to close those curly brackets. Then I'm going to copy this for loop, the beginning of it, and I'm going to come down here, and our mover update and mover display down here is throwing us an error because we need to do sort of the same thing. So I put this for loop, and then I need to tell it which mover to work with. So again, I'm going to use this same square bracket I and do that after the word mover, but before the dot. So the same thing down there. Then I'm going to close my curly brackets. So this is saying every time you run through the draw loop, you're going to run through this for loop, and for mover number 0, update, mover number 0, display, next time through this for loop, mover number 1, update, mover number 2, or mover number 1, update, mover number 1, display, go back through the loop again, mover number 2, update, mover number 2, display, and then keep going. Okay? So now if we run this, still looks the same. I wanted 3, but it looks like we only have 1. So that's because each of them are starting out with the same starting point, and they're each moving at the same rate. So it's just going to look like 1 because I'm giving them all the same information. So what I'm going to do is I'm actually going to come up here and I'm going to make an int variable called num circles, and I'm going to set that to 12. Okay, and this num circles is going to really come in handy. So I'm going to, where I had these 3s before, I'm going to put in num circles. So it's going to go there. It's going to go right here in my for loop, and it's going to go right here in this for loop. Okay, and I just want to make sure I did that right. Good. So I'm going to come over to my circle object, and here we made a float called center. Oh, I forgot one thing. Okay, this is this sticky, interesting, complicated, weird point. So when I initialize my mover, I want to also assign it a number based on its I number. Okay, so when it makes the mover, I want it to pass this I value into the circle object. So I'm going to put an I there, here when I make the circle object in that parentheses. Then when I go to my circle object here, this is sort of like the setup for it. This is where we define the object as we make it. So this only runs once per object that we make. I'm going to make an int here called temp I, because it's just sort of a temporary holding place. And what's going to happen is this value that comes in here is going to be assigned to here. Then I'm going to come up here. I'm going to say int I. And I'm going to say I equals temp I. Okay, so let me walk you through that. So when we run through this for loop, each of these movers is assigned an I value. That value is passed into the circle object. That circle object receives it here, and then it assigns that temporary variable to this integer called I that we made here. So now we have this I value, and now we can set our center point based on that value. So what we're going to do is we're going to say center equals, then we're going to map this I value, which we know is from 0 to num circles, right? Because we set num circles, okay, in our main sketch, so we know that that's as many circles as possible. Then we're going to set that from 0 to 2 underscore pi. Okay? So this is going to change the center for each of these circle objects that we make, and is going to give each one a unique position based on this I value. Okay? So now when we run this, we have 12 circles on our circle, all rotating together. Okay, that was a little bit hairy. Did everyone get that? Is that working for everyone? Yeah, good, cool. Okay, I'm going to push on because I got to leave in just a couple minutes to go do some stuff for my degree. Not super important, but what I want to do is I want to show you how we can change some of this stuff. So we're going to make a new value couple new things, and we're going to call them float C and then float sine C. And this C is going to talk about color. So if we come down here to display, we're going to say sine C equals sine of C. And that's going to give us, again, that -1 to +1 range. So we're going to map that from 0 to 255. Or sorry, our incoming values for that are -1 to 1. We're going to map that from 0 to 255. And I forgot a comma. Cool. Then what we're going to do is we're going to say C, we're going to increment C, but we're going to increment it based on its I. So we're going to say map I from 0 to num circles. And then we're going to say from 0.01 to 0.04, let's say. And then we're going to say fill sine C. So what's going to happen is we're going to get the sine value for C, so it's going to go up from -1 to +1, and we're mapping that from 0 to 255, which is going to change the color of our fill, but they're going to change at different rates because we're incrementing C in a range from 0.1 to 0.4 based on this I value. Okay, so now if we run this, we get these sort of cool wavering black to white circles. I'm going to try and do this a little bit quicker. I'm going to make, so excuse me if I sort of bully through this, but I want to show you sort of where this can end up. So we're going to make another float called cosine of C. And we're going to do basically the same thing. Pick our cosine instead of our sine. So you can just, all I did was copy this and pasted it and change this sine to cosine. And then I'm going to change this from 100 to 255. And then down here in the fill, I'm going to add a little bit of green, and then I'm going to say cosine of C. And when I run this now, we get some nice colors. So that's pretty cool. But I want them to not, I want to change their opacity. So it's going to be, if it's 0, then they're all the way ghosted, but then if it's 255, then they're all the way present. So I'm going to choose about 100. And so that's cool. And then I'm going to say, oops, no stroke, because I don't want those borders. And so that's cool. And then I'm going to make these a lot bigger. I'm going to say that these circles are 400 by 400. And now if I run this, that's the good stuff. Look at that.
Awesome.
I have a question.
Yeah.
Did you know what colors they were gonna be, like based on the numbers you put, or like?
Sort of. Yeah, that's a good question. So when we do the fill, the first value determines how much red, and then the second value determines how much green, and then the third value determines how much blue.
Okay.
So I know that with the red, I'm going from no red to a lot of red, and from the blue, I'm going to some blue to a lot of blue. So if you want, you can sort of, fudge those numbers and figure out, what looks good to you, what fits your vibe. Yeah, there's no wrong answer. You can put in values, and if it doesn't look good, then you change your values, and then that's the sort of art of it, right? And that gets me to sort of the point that I always try to make, which is like, the goal of this thing that we're doing here, this workshop, is not for you to copy exactly what I'm doing, but to say, oh, I know how to make something, I know how to make it move, and I know how to make it change colors. And so I'm going to do something that's totally different. I'm going to make a project where, it's not circles that's moving, but it's squares, but they're flashing as they move, or they're moving in wild ways, or things like that. But this is just sort of showing you the mechanics of how to make something like this. Okay, one very quick thing before I leave. So this C value, this is changing the color rate dependent on this I value. I want the speed to do the same thing. So I'm going to copy this, this map part of this here, and I'm going to paste it here where I increment my center. So let's go from 0.01 to 0.02. Now if I run this, the speed that they move is going to be, each one's speed is going to be a little bit different. So maybe if I make this 0.35, let's make it a little bit faster. There we go. And so if you sort of watch this for long enough, there are these sort of collision moments where they go into 4 circles and overlap and make cool things like that. 3. So I have to run. I'm going to leave you in the